Hi, today we are going to discuss bit order or bit arrangement in a single word or double word memory in a Siemens PLC. But before that, we are going to have a recap on our previous studies in electronics or electrical or any related subject. I know for sure that you already encounter binary numbers. So I will just challenge you to uh, convert this binary number into decimal value. Okay, let's convert this together. So as we all know, the arrangement for this binary will be from right to left. So the decimal value will started from right to left. So that arrangement is what we call LSB or least significant bit. So the value will be like this: 0. So what I'm writing is the uh, decimal value of the bit. Okay, so you'll just add that to itself, then that is the value. Okay, so this is the decimal value, and then this is the binary bit order. So the bit. Now we'll copy this one here: 0 1 1 0 1 0 0 0 0 1. So in binary, those that having 1, we will add that together, and then that is our decimal value. So we will add this all, this one. So those only having 1 equals this one. Okay, so here's your decimal value for this binary number. So 150. So if you have doubt, you have there your calculator in your desktop. You can open it and then change that into programmer mode. But I'm sure that this is the value 150. Okay, now let's go back here. I will just ask you one thing. How many bits in one byte? So if you don't know, one byte is equals to 8 bits. Okay? One byte is equals to 8 bits. And then one word is equals to 2 bytes. And then double word, of course, from the word itself, double means 2 words. So in one word, since you have 8 bits in one byte, one word is equals to 16 bits. And then double word is equals to 32 bits. Okay, now if we apply this in Siemens, if you, for example, I will just, typically you are using these bits. New programmers in Siemens only using bits. Now, you want more interesting. For example, you are now dealing with temperatures, you are dealing with uh, set points, for example, then you are dealing with analog values. Now, this one will make you confused because sometimes you are overlapping the address. What am I talking about? For example, you are using M0.0 as your start command in the HMI. And then while as you are also using your set point MW0 for your set points, then it will have a impact on your bits. Why? I will show you why. One word will be represented as MW in address in Siemens. So MW stands for memory word. So as we all know, one word is equals to 16 bits. So if you are started with MW0, if your address is MW0, this one 0, that is comprises of memory bit M0.0 until M1.7. So if you're using a set point MW0 to put a command or to put a value on a certain set point, then you might be affecting these bits as well. Okay? Understand? What if I'm using double word? So the double word, if you are using memory, it will be like this MD0. MD0, this is the address. Start with this address. So as we all know, double word comprises of 32 bits, right? So from 0.0 to 3.7. So this one is the components or the bits that comprises this double word value. What if my address is MD4? So of course, it will start the bit from M4.0, not anymore 4, not anymore M0.0 because you started your address by 4. So F6, then I will be starting from 6 here, M6.0 until 7, 8, 9.7. So it will be ending here 9.7 if you are using MD6. I hope you got it clearly. What if I'm using here MW4? So what are the bits that composes MW4? So MW4 will be composes of M4.0 until MW5.7. I hope you got it. Now, let's proceed to decimal value. This one only a representation of a 1 byte. So this example is only for 1 byte. How about if we are applying this in a one word? So one word will be different now. It will add here another 8 bits. So like this, 8 bits. So just think of it, this is a binary number. So it will be binary numbers. The arrangement of the decimal value will not be from right to left like this. Rather, it have a what we call byte swap. It will swap the byte from here. Don't be confused, this is only applicable for decimal value. So instead of 0 will start here, 0 will start from the next byte of your word. So word, which means 16 bits, you will not be starting 0 from the first bit, but you need to start the zero value of your decimal to the next byte, which is the 1.0. Understand? So 1.0 here will be your zero value, or 1. And then 2, 4, 8, 16, 32, 64, 1 to 8. And then the next will be the first byte. So this is what we call byte swap. So it will swap. This is only applicable for decimal value. I hope you understand. Now, this is only for single word. How about if you are dealing with double word? In double word, as I mentioned, it composes of 32 bits. Now, the decimal value arrangement will be again changed. From a single word, it will swap the byte. In double word, it will swap the byte as well as the word. So we will have a word swap here. See? Instead of starting 0 from M0.0, you will start 0 from 3.0, not 2.0, because you will also have a byte swap in double word. So it will be like this. 0 decimal value will be from 3.0 until 3.7, and then it will follow to 2.0, since as I mentioned, it will have here a byte swap. There will be a byte swap happen here as well as here. Okay, I hope you understand. So this is only for decimal value. The bit arrangement will be the same, only the decimal value will change. Now, let's go back to how to take, or how the bit was ordered, or how you call a bit in a word. So I have here TIA version 16. So if you don't know, this is the newest version of Siemens. Okay, I will just create one function here, one block. Normally, if you are a programmer in Siemens, my technique is I will first gather all the tags. So this is a typical view of TIA. So here tags, I will just show all tags, and then I will put everything tags that I want to put. But for now, I will put here my word. So this is our word, double word. So now I will be discussing you how to take a bit in a double word memory. So you have here. Now, there are two ways to take bits from a word. So, but first, I will introduce the block from our OB. Now this is our FC. Now how to take bits from double word. For example, I am taking 0.6. So first, the easiest way, I can just directly put M 0.6. I can put like that right away. Another thing is to take it indirectly like this. Copy this copy your tag name, and then separate with dot, percent symbol, and then your bit number. So this is X. What is the bit number? 0.6 will be your sixth bit, right? So I will just put 6 like that. So what will happen here, if this one will trigger, this one will also trigger, because this is all the same. So that is how you take bit from a double word memory. So I will, how about if I will take this 3.2? So again, two ways. You can directly uh, assign 3.2 here, or you can use this X. 3.2 will be the 26th bit. Okay, very easy. I hope you understand. Again, thank you, and don't forget to subscribe for you to know my next tutorial or videos. Thank you.